Alrighty. In today's lesson, we're going to be looking at chapter 11. So we're going to be looking at lesson 11.1, which is solving system of linear equations by both substitution and elimination. Hopefully this feels like a review over college algebra before we get into more of a pre-calc concept in the next section. So again, this will be solving systems of linear equations. We're going to focus on substitution and elimination. All right. A big thing in this section as a review part is you need to know that there's three type of answers. You can have one solution. So meaning there's only one answer. And this is called consistent and independent answers. I think in the homework it asks you what kind of answers. So this is what it's looking for. So independent. Oh. And graphically, what that means is if I graph two things, that intersection would be the one solution. You could add potentially no solution. This is called inconsistent. Which basically graphically means that it's two lines that are parallel. So let's pretend these are parallel, but meaning they do not intersect, so there would be no solution. And you can have infinitely many solutions. This would be consistent as well, because it does have an answer. That's what that means. So consistent means has an answer. Inconsistent means doesn't have an answer. Independent would be one solution, but for this one, this would be dependent because it has multiple solutions. And what that basically looks like is I can have a graph, and then my graph like right on top of it. So you can see it crosses infinitely many times, not all solutions, but an infinite amount of solutions. All right, so that's pretty much all that's covered in there. And then it gives you some examples of how to solve using substitution and elimination, which is what I'm going to do with you as well. So you have some in the book, and then I'll give you some as well to help you on the homework. So let's first look at number one. So in the first 15 set, it tells you to solve the system by substitution. So it does want you to practice both concepts. I think even on the homework, it's going to break it down by step to make sure you are doing it by substitution or elimination. So it's not like one of those questions where it's just say solve by this and then it just wants the answer. It does break it down by steps. So do understand both of these parts, but it's not too terribly hard. So you're given 2x minus y equals negative 12. And 3x plus y equals negative 13. When you are asked to solve by substitution, you just need to pick a letter to solve for. Try to pick the letter that has the smallest coefficient. So when I'm looking at this, I see it has a 2. This one technically has a negative 1. This has a 3, and this has a positive 1. These are both kind of the same distance, but you want to look at this one because I won't have to divide. So I'm actually going to solve for this y. It really and truly doesn't matter which one you choose. It's just depending on which one you choose, you might be dealing with fractions until the end of the process. So try to pick one that has the least amount of fractions that you'll have to deal with. So if I solve this one, so 3x plus y equals negative 13, all I'm going to have to do is just subtract 3x. So in this case, I'm going to write it as negative 3x minus 13. If you wrote it as negative 13 minus 3x, you're correct as well, but my mind always goes to the mx plus b format. All right, once you have solved for a letter, your goal then is to take it and substitute it in the other corresponding equation for that letter. Here's the next set of work. So now I'm going to write it as 2x minus, I'm going to substitute y for this equation right here. So but when I substitute, I always use parentheses. So it's going to be negative 3x minus 13. Parentheses helps me to understand that there's actually a multiplication going on here and not just a minus this equals negative 12. You now have an equation with only one letter. So now we know how to solve that algebraically. So let's work it out. So we'll get rid of the parentheses first. So negative 1 times negative 3 gives you a positive 3x. Negative 1 times negative 13 gives you positive 13. Combine like terms, so 2x plus 3x gives you 5x plus 13 equals negative 12. Then subtract 13. This will then give you negative 25 divided by 5. So you get x equals negative 5. All right, so once you have x, you didn't take that answer and you substitute it back into the equation that you solved for that second letter. So then I go, all right, well, this is going to be y equals negative 3. Substitute that x in as negative 5, again, using parentheses to indicate multiplication, minus 13. Then this will give me 15 minus 13. So then this will give me 2. To write your answer out, you write it as x comma y. So for this one, this would be negative 5 comma 2. That would be the correct answer for this one, meaning that if I plug in negative 5 in for x and 2 in for y for both equations, the first one will give me negative 12, the second one will give me negative 13. All right, so let's do another one. Let's look at number 8. Number 8 says 3x plus 6y equals negative 12. Then you have 2x plus 4y equals negative 8. Again, I'm going to solve for what I think is going to be the easiest. In my concept, 2 is the smallest number, so I think 2x would be the easiest letter to solve for. So solving for x will be, I would subtract 4y first. Again, I always put the letter first, but it doesn't matter. And I'm going to divide every term by 2. So this now gives me negative 2y minus 4. So I did get to avoid fractions. That came out nice and clean. So then I'll take this answer and I'll substitute it in for this letter. So I now get 3 times negative 2y minus 4. Again, use those parentheses to indicate that multiplication. Plus 6y equals negative 12. Once again, I have an equation with only one variable. So I'll distribute. So this gives me negative 6y minus 12 plus 6y equals negative 12. Now watch what happens. When I combine like terms here, negative 6y plus 6y cancel each other out, and I'm actually left with negative 12 equals negative 12. When you end up with a situation where your variables get canceled, but you're left with a true statement, and this would be infinitely many solutions. Make sure. So this is technically, I've always taught it, infinitely many solutions, but they're going to take it a step further. So since your y can be basically whatever it wants, you're going to go back to this equation for your x. So your actual answer will be written like this. Parentheses, so a little, I think they call it a cursive bracket. And then you're going to say, all right, my x equation is negative 2y minus 4, comma, y, parentheses. Meaning y can be whatever it wants, but whatever y is will dictate what my x gets to be. And then you just kind of wrap it up stating that y, so it's such that, that's what this little bar means if you've never seen it before. Y is included in the family of real numbers. And then you close it out. So that's kind of how they want you to write the answer. So you take whatever the equation that you solved for, had you solved for, and there's multiple ways to answer this question as well. Had I solved for like x or something, I would have got an equation with y, and I would solve that x can be whatever, then y would have an equation. So there is multiple ways to answer this question. All right. Not infinitely many, but multiple ways. So there's one right there. So let's look at another one. Let's look at number 9. This one says 2x plus 5y equals 33, and 3x equals -3. So obviously the easiest one to solve for will be this x. So that's going to be 3x equals -3. I'll divide both sides by 3. So x equals -1. I can then take that value, substitute it into the other equation. And so I get 2 times -1 plus 5y equals 33. This gives me -2 plus 5y equals 33 plus 2 plus 2. So 5y equals 35. Divide that by 5. Y would give me 7. So in this case, my answer is -1, 7. So it's really nice when you have one that's already only got one letter to solve for. All right, so those are pretty good examples for substitution. Let's talk about elimination. So let's look at number 17. Number 17 is -2x plus 3y equals 13, and 4x plus 2y equals -18. All right, so for elimination, we have to make sure that it is in standard form. Standard form for a linear equation is ax plus by equals c, meaning the x and y needs to be on one side, the constant needs to be on the right, x needs to come first. After this point, there are different processes to do this. If you're really good with your number sense, you're just trying to find a number that you can multiply to one of these equations so that when you add the two equations up, it will eliminate one of the variables. So for instance, I see a -2x and a 4x. I see if I just multiply this guy by 2, this would be a -4. And when I add -4 to 4, it would give me 0. So what I would do is I would go, all right, I'm going to eliminate my x by multiplying the entire equation by 2. And when you do that, you now get -4x plus 6y, don't forget to do the constant as well, equals 26. And then I'm just going to rewrite the other equation. If you are not good with number sense, you would simply take the first number, multiply it to the top, take the second number, or the first number of the top equation, multiply it to the bottom, but change its sign. So it just kind of depends on where you're at. Your goal, again, is to figure out a number to multiply to one of these 4 letters in order to multiply everything and be able to add them so that they cancel. So for instance, I could have multiplied this by a positive 1/2 because this will make this a 2. Or I could come over here and I can multiply this guy by 2, but then multiply this guy by a -3 in order to make the y's cancel. However process you want to do, there's wrong ways, but there's multiple ways that you can go. The goal is, again, to multiply the equations by something in order to have the letters be added up and eliminate one of them, at least one of them. Sometimes you'll see that both will eliminate, but the goal is to eliminate one. So now that I've kind of figured out, all right, I now have my 4 and -4, and if I add -4x plus 4x, it is eliminated, hence the elimination method. After that, I go to the next variable. 6y plus 2y gives me 8y. 26 plus -18, was that negative? Nope, that's positive 8. And then from there, I then divide. So I'll divide both sides by 8. So y gives me 1. Once I have an answer, I can plug it into any of the original equations or any of my new equations. I naturally default to the first one, but it really doesn't matter. So negative 2x plus 3, I'm going to replace y with what y is. So that's a 1 equals 13. 3 times 1 is 3. Subtract the 3. So negative 2x equals 10. Divide by negative 2. So x equals negative 5. So in this case, you get negative 5 comma 1. And there's your answer. So that is a elimination method. Let's do another one. Let's look at number 19. 19 is written as x plus 2y equals 17. And 3x plus 4y equals 39. Again, your goal is to find something to multiply to either one of these equations so that when you add the equations up, you eliminate it. You could probably see a few things. One, you can multiply this equation by a negative 3. 2, you could technically have multiplied this by a negative 2 to make this a negative 4 to eliminate the y as well. So there's a couple of different directions there. Or you could get real adventurous and multiply this by a negative 1/3 to make it a negative 1, or multiply this by a negative 1/2. But then you'll be dealing with fractions, but it is still a process. So I'm going to distribute this negative 3. I saw that was the easiest in my head. Maybe a negative 2 would have been easier for you. However you feel, as long as when you multiply by a number and you add the two equations up, you're able to eliminate one of the variables. So this becomes negative 3x minus 6y equals 17, 34, 44, 51. So negative 51. Okay. And then the second equation is written as is. So now when I add negative 3x plus 3x eliminates the variable. That was my goal. Negative 6y plus 4y gives me negative 2y. And then negative 51 plus 39, that would give me, was that negative 12? So that'd be 49 and then 2 more. And then I divide by negative 2. So I get y equals 6. I then take that and I plug it into any equation. Again, I naturally default to the first one, but it really and truly does not matter. So this becomes, again, x plus 2 times 6 equals 17. And then x plus 12 equals 17. Subtract 12. So x equals 5. So therefore, I get 5 comma 6. Okay. So there's that process. Again, there's multiple ways of numbers to multiply. Just try to multiply by a number in order to eliminate a variable. Let's do one more to make sure you have enough examples. Let's look at number 20. This is 5x minus 10y equals 9. And then negative x minus 4y equals, oh no, that's right. Nope, I went down to the wrong one. So that's 5x minus 10y equals 9, then negative x plus 2y equals negative 3. All right, so in this case, I see that this is a negative x and this is a positive 5. So if I just multiply this equation by 5, I can eliminate this x. Now watch what happens when I do this. First equation, there's a change. Second equation becomes negative 5x plus 10y equals negative 15. So when I go to add this, 5x plus negative 5x eliminates, but negative 10y plus 10y also eliminates, leaving me with nothing left on the left side. And then 9 plus negative 15 gives you negative 6. So earlier we saw when we had a true statement, it was infinitely many solutions. When you end up with a false statement, that means there is no solution. You might also see it written as this. So it's an empty set. All right. So good. I feel like we did good on substitution, elimination, and you saw both special cases. All right. But let's look at what happens if there is 3 equations. So let's look at number 33. So we have x plus y equals 4, y plus 3z equals -1, 2x minus 2y plus 5z equals -5. My personal opinion, when it comes to solving three variable equations by hand, I find substitution to be the easiest process, but you are able to use the elimination method, which there is an example shown in the book. So this is what I'm going to do. I see that these two equations both share y. So what I'm going to do is I'm going to solve for their other variables so that I have two equations that will both have a y in them. So when I substitute those equations in for the third equation, I'll have a gigantic equation with nothing but y's, and I know how to solve for a one variable equation. So that's the process I'm going to go through this for this one. So I'm going to solve for x. When I do that, I subtract y. So I get x equals -y plus 4. I'm going to solve for z this time. So I'll subtract y. And then I'll divide by 3. So I now get z equals, I'm going to call it -1/3 y minus 1/3. But you could have kept it written as y over 3 if you wanted to. I just like having the coefficients there. All right, now that I have equations for both my x and my y containing a y, I'm going to plug it into my x and my z with the y. So this now becomes 2 times -y plus 4. Again, that was in parentheses when I plug in the indicate multiplication, minus 2y plus 5 times my z, which was -1/3 y minus 1/3 equals -5. Again, I now have an equation with nothing but y's, so now I can solve it. So I'll distribute. So this gives me -2y plus 8 minus 2y. Distribute this out. So this will give me -5/3 y minus 5/3 equals -5. I'll combine like terms. So -2y minus 2y is -4y. -4y minus 5/3. So -4 is the same thing as -12/3. And then -12/3 minus 5/3 would be -17/3 y. And then 8 minus 5/3, right? 8 times 3 is 24, so it's the same thing as 24 over 3. 24 minus 5 would give me 19 over 3 equals -5. I don't want to deal with fractions anymore. Well, I guess I can. It doesn't really matter. You could have right here multiplied everything by 3 to get rid of fractions, but fractions aren't too bad in this one. So I get -17/3 y equals, all right, -5 times 3 would be 15. So it's the same thing as -15 over 3. So -15 minus 19, that would be, so 15, 19, 20, 34. So -34 over 3. And then to get rid of a fraction, you could technically, yes, divide by -17 over 3, or you can multiply by its reciprocal. So that's what I'm going to do. So I'm going to multiply by 3 over 17 to eliminate it. But if I do it on this side, I must also do it on this side. Now these 3's will cancel each other, but then this becomes -34 divided by -17 because it's on the denominator side. So that tells me that y is actually equal to 2. So again, you could eliminate fractions up at this point by multiplying everything by 3 and not dealing with fractions, but these fractions weren't too hard. So I left it as is, but totally, completely up to you. Now, once you have an answer for this variable, now you just do a bunch of back substitution to solve for the other two letters. So in this case, this becomes -1/3 times 2 minus 1/3. So in this case, this is -2/3 minus 1/3. And believe it or not, that is going to be -3/3, which is -1 for my z. Do the same thing here. So this is now going to be x equals -2 plus 4. That just becomes a -2, so that becomes a +2. So your answers are written as x, y, and z. So in this case, the answer is 2, 2, -1. So what that means is if I plug those answers into all three equations, they'll all give me true statements. So again, I find substitution to be the easier process for us, a three equation or three variable system. You could use elimination, and the book comes up with a good example of that. However, if you want me to do an elimination method, just let me know. I'll make another little short video and send it to you. Let me know on those. Two more questions, and of course, like any other of these homeworks, they love these word problems. So I'm going to go and jump at a couple of them. So let's look at number 54. Number 54 says, how many ounces? So how many ounces each of a 12% alcohol solution and a 30% alcohol solution must be combined to obtain a 60 ounces of an 18% solution. If you remember college algebra, this is called a mixture problem, and we had a way that we could solve it just using one variable. I'm going to show you how you can now solve it using two variables. So the fact that we know that there is a total of 60 ounces, then you just need to name your variable. So I'm going to let X be the ounces. I think it's OZ for ounces. I might be wrong. I'm not going to mark that. I just don't want to feel like, I'll just write it out. Ounces of 12% solution. And I'm going to let Y be the ounces of the 30% solution. All right, so what that means is if I know there's a total of 60 ounces, then I know however many ounces of 12% solution plus however many ounces of the 30% solution, I will get a total of 60 ounces in the mixture. Now, to write the next equation, I know however many ounces of 12% solution, that would give me 0.12 of that solution. So however this amount of ounces is, I need to take the percentage of that solution plus whatever the 30% of that solution of Y is, gives me the 0.30 Y. So this is what we were kind of taught in college algebra, but we said X, and then this would be the 60 minus X at this point. And then we went through a process of solving it that way. This is now a way to solve it using two variables, because I know that this needs to equal the point, was it 18% solution? So this would be the 0.18 times 60. This time I know what my total is, and I know what I want my grand total is. So here is your equation. Just an FYI, I find this to be the easiest to do this by elimination. I will say 0.18 times 60. Actually, I don't know. Maybe it would just be easier to maybe substitution. I don't think it really matters. Both the methods are just fine. But I will type this in. 0.18 times 60 is 10.8. So just to make life a little bit easier. All right, so on this one, I'm just going to pick a variable to choose for. I'll solve for Y. It really doesn't matter. So when I do that, I would move the X over. So I get Y equals -X plus 60. So I would subtract X on both sides. Once I have this equation, I'll now plug it in here. So this will now give me 0.12X plus 0.30 times -X plus 60 equals 10.8. Distribute 0.12x plus, or minus 0.3x, and then that would be 0.30 times 60 would give me 18 equals 10.8. So I'll combine. So 0.12 minus 0.3 will give me 0.18x. Subtract the 18 over as well. So 10.8 minus 18 gives me negative 7.2. So then I'll divide by this negative 0.18. So then I'll take over here 7.2 divided by 0.18, and I get 40. So to answer this question, there would be 40, because that's what my X is, 40 ounces of 12% solution. That's why it's good to label it. So when you get these answers, you know what to do. And then now I can back substitute this 40 in right here. So this would be negative 40 plus 60, which just comes out to 20. So that means then there's 20 ounces of 30% solution. Could have also done elimination by multiplying this one by like negative 0.12 or negative 0.3 or whatever to cancel out one of the other ones. But again, process didn't matter. All right, let's do one more word problem so that I know you have it all. So let's look at number 57. This one says, Jack and Tyler went shopping for summer clothes. Shirts were $12.47 each, including tax, and shorts were $17.23 per pair, including tax. Jack and Tyler spent a total of $156.21 on 11 items. How many shirts and pairs of shorts did he buy? So again, I'm going to start off by labeling my variable. So I'll let X be shirts, and I'll let Y be shorts. It does not matter how you label it, because when you pull your answers, then that is when the correct answers come out. So if you were to say let Y be shorts and X be shirts, at the end of the process, we'll both get the same answer for our shirts and shorts. All right, so we're told there's a total of 11 items. So that means that however many shirts and shorts I bought, there were 11 total items. And then I'm told that for shirts, it is $12.47. And for my shorts, it was $17.23. And it gave me a grand total of $156.21. So there's your equation. I'm going to solve it just like the last one. Just because I think elimination would be a lot harder because you would have to multiply by negative 12.47, but it is still a process. So again, I'm going to solve for my Y. So again, if I subtract X on both sides, I get Y equals a negative X plus 11. Take this answer and I'll plug it in for my Y here. This gives me 1247X plus 1723 times negative X plus 11 equals 156.21. I'll distribute. So this gives me 1247X plus 1723. Oh, no, not plus, negative 1723X. And then we'll do 17.23 times 11. And we come out to 189.53 equals 156.21. I'll combine these. That's going to be 12.47 minus 17.23. So that comes out to negative 4.76x. And then I'll subtract this right here. So now I get 156.21 minus 189.53. So that give me negative 33.32. I'll then divide. So then I'll take that answer, divide it by negative 4.76, and I get 7. So since I now know what X are, even if you would have switched this, you would have got probably like 4, because if I plug in negative 7 plus 11, that just gives me 4. So that means there were 7 shirts and 4 shorts. Right? And that's pretty much it. So hopefully you found this more as a review from college algebra. We will definitely give it a pre-cal spin in the next lesson. But if you need any help, please reach out. Until then, see you in the next video.